Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, Task Scheduler. So we have a list of CPU tasks that are represented by letters, and we have a calling time. And basically, a calling time means once you do a task, let's say A, if the calling time is 2, that means we can't do again until 2 intervals or 2 slots have passed. And each cycle or intervals here allows the completion of 1 tasks. Basically what it says here is what I just said, where tasks, you can complete them in any order. The only constraint you have is that for a same task, so task with the same letter, it has to be separated by n intervals. So basically there is a calling time of value n. And the goal is to return the minimum number of intervals that we need to complete all the tasks. So let's see what this looks like in the first example to understand this. So for the first example, what will happen is we'll do A first. And so we'll do this A, for example. And then we can't do A right away because there is a calling time equal to 2. And so we have to do something else. The only one we have is B. So we do this B, for example. And then now we can't do A again because there is only 1 interval that elapsed so far. We need 2. And so we can't do A and we can't do B again because there is 0 elapsed time since we had B. And so we have to have an idle one here. And idle basically we do nothing, but we do count it as part of as an interval. So we have an idle interval here. And then now we can do A because now we have 2 intervals between this A and this position. And so now we do A. So let's say we do this one. And now we can do B because now between this B and this position, there are 2 intervals. And so now we can do this B. And now again, we can't do A because there is only 1. And we can't do B because it's right next to it. And so we have to have another idle interval here. And after that, we can do A because now we have 2 intervals in between. So we do A, let's say we do this one. And then now we can do B because there are 2 intervals in between. And so we do B. And so now we did everything. And how many intervals we did? Well, 1 here, 1 here, another one here, another one here, here with the idle one. So 3, 4, 5, 6, 7, and then 8. So total is 8, and that's what we return. So that's the idea. Now, if you take a look at this example, what sort of observation we can make? Well, the first one is, let's say if we had only maybe just 3 A's and 2 B's. And maybe let's say the B's were first. What does this tell you? Well, this we should still start with an A. Why? Because there are more A's, so to more optimally be able to have enough space for less time for the next A, we want to start with an A, right? So that's the first observation, is it's good to start with the interval with the most occurrence first, and basically as you go, take the next highest frequency that you can, with of course the constraint with the of the calling time that we have. Okay, so that's the idea here. Now, if you take a look at the second example, this still is valid here in this case as well, because which one should we take? A occurs 2 times, B 2 times, C 1 and D 1 time. So it makes sense to take either A and B first. And so that's what we do here. So we did this one, and then we do the next one that has the highest frequency, well, B, because it still has 2. So we do this B. And now we can decide, it doesn't matter because each of them is now 1 occurrence. We can put them in any order we want. We can put A here or put A here. It doesn't really matter. We just put the 4. There is no constraint because they are all different. And so total is 6. And so this is the exact idea we will apply, is we will put them in a heap so that we can grab the maximum frequency first. But we need to take care of the constraint, where basically if there is nothing that we can take, we don't put back, first we don't put back in the heap and unless we can take. So let me actually just explain this a little bit more. So let's say we do a heap here, so of the occurrences. So in this case, well, our heap will have, for it to be a max heap, let's say in Python we'd have to do minus, but for now let's just forget about that for now. So we'd have 3 of A's, and let's say we have 2 of B's. I'll go with the example where B is smaller, where B is only 2. So if we do this, then what should we do here? Well, we will take first, so we will keep hopping from our queue, and so we will hop first, we'll pop first 3 and A. And so what should we do? Well, we should increment our count of how many intervals we need by 1, because we just let's say place it A. And so let's say maybe we place an A like this. Okay, then what happens next? Well, what happens next is that now we should decrement this to 2A, but should we put it back in the heap? Well, if we put it back in the heap, since like the heap becomes something like this, if we do that, the problem is next time we'll pop A again because the values are equal, and so the tiebreaker is the letter, so we'll pop this one to A. But that's not valid because we didn't respect the calling period. So how do we respect the calling period? So one idea is, let's not add it back to the heap until the calling period has elapsed, right? And so how do we then keep track of this 2A that we need to add back? Well, let's just have something, maybe call it waiting for being eligible to be added again. And in that one, let's add these 2. But what else do we need? Well, we need to know when we reach the calling time, which is equal to n. We need to know when we reached it. So let's maybe just have a time here that tracks if we reached the calling time or not. And now we can just go through our heap, but on each iteration through our heap, we want to check if this reached the calling time. Let's say in this case where the calling time is 2. What will happen is that the second time, since our heap now has, after this, our heap time now has only 2B. So what will happen is we will pop B, right? So now we'll pop 2B. And now if we pop 2B, what happens? Well, we put B because we just popped that one. And increment our interval. So now our interval is 2. But we can't add B right away, right? And so we add it to our waiting to be eligible. With 0, the frequency is 1 now because count minus 1 each time. And then this is B. But each time before adding this, we should increment the time because there is just a new interval in between now, right? Now there is an interval in between. And so we should increment the time for this one. And then we can add this one here. Okay? And we check, did we reach the calling time? Not yet, because it's 2. And so we go again. Our heap is now empty, but as long as our waiting eligible is not empty, we should keep going because we need to wait for this to be eligible to add it back because we need to add all of the tasks. So we can do a while loop here for heap. Either the heap has something or the waiting to be eligible has something. Okay, so now in the next iteration, what happens? Well, in the next iteration, we find that there is nothing in the heap, so we don't do anything. So we do nothing. Our heap is empty. And then we increment the count because we are still doing an idle time waiting. But now if you look, we increment 2 and increment this by 1. Now we see A reached it is now eligible. So now that A is eligible, we add it to our heap. So whenever one becomes eligible, we add it back to our heap. Okay, So now on the next iteration, what happens is when we pop, we'll pop to A. Okay, and so we add back A. Of course, don't forget that we did add an idle interval here, so we add back A. And what happens next? We continue here, so our calling time now, the count increases by 1. Each time we increment the count, and the waiting eligible we increment by 1 because we just added another interval. And now B is eligible, right? Remember, we popped this A. So we remove this, and now B is eligible, so it has 1 and B. Okay. And we add to waiting for eligible, we add A because there is still 1A waiting, right? And this, we remove it because we added it to the heap. And now the next time the heap pops B, and so the count is 5. We add B to our intervals here, like this. Okay, and now what else happens here? We added that we have 5, and then we increment this by 1, and then this one here is no longer there. And now the next time we have nothing to pop from the heap, but we increment this by 1, so this is now 2. And now it reached the calling time, so we add it to our heap. And so when we add it to our heap, we pop it next time. So the count here was 6 and 7. And now we can add the A here. And now we are done. Okay? And this is what we return, because now both waiting to be eligible, we removed this already, and the heap is empty. Okay? So basically you can think of it as we keep track of the eligible ones already in the heap, but we keep track of them in order of frequency so that we can pop the highest frequency first, right, to have a higher chance of finishing with it fast. And then for the ones that are not eligible yet, that are waiting for the calling time, we put them in this waiting to be eligible array, and we track how much calling time has elapsed. And once we reach the desired calling time, we add it to our heap to be processed, right? And that's pretty much it. Pretty straightforward if you think about it. It's just applying the exact logic that we do by hand, okay? So now let's code it up and make sure that it works. So first thing we need to get the occurrences of the tasks, okay? And then we need a heap. And then we can go through the frequencies of the values. And we can push to our heap. Now for a max heap in Python, we need to just put it in negative so that the highest value is popped first. And we need to keep track of the ones that are waiting to be eligible. Okay, and we need also the count that will return at the end. We'll initialize it to 0. And as we said, we need to wait. We need to keep going as long as there is something in the heap or there is something waiting to be eligible again and be added to the heap next. So let's just initialize our frequency to 0. And we check if there is any element in the heap. We want to pop the frequency of the highest frequency letter from the heap. So that would give us a frequency and a character. But remember, this frequency is negative. So we want to convert it to be positive because we already made it negative here. And we want to subtract -1 because we just used one of them. We just used it to create an interval that we will increment the count for here. Now we need to increment count regardless if we popped or not, because if we in the else here, if we don't pop, then that means we need an idle interval. Okay, and now we can go through the eligible first here. If the frequency is bigger than 0 for the popped element, I remember if it's equal to 0, that means we didn't pop anything. But if we popped and it's bigger than 0, that means there are remaining tasks to be placed, but we need to wait for them to be eligible, right? And so we do waiting for eligible, and we append. Now we of course need to add the frequency, we need to add the character, and we need to add how much time has elapsed, and initially 0, right? Now we need to also go through the waiting for eligible to see if there is any character that became eligible. And so we check if there is any of them where this new time is equal to n. So now this means basically is now eligible to be processed. And so to do that, we want to add it back to our heap. What should we add? Well, the frequency, of course, and the character. But remember, this frequency is positive. And so we just need to add it negative so that it works with the max heap. Okay, otherwise, what should we do? Well, we should just increment the time. Increment the time here. And so we can just say so we increment the time first by 1, and then we add the frequency and the character. But there is one problem. We shouldn't change something as we are traversing it, right? Because that will be, basically we'll keep adding, and this will keep going again and again. And so let's just have a temporary array where we keep track of values. Okay, and so we do that, we append here, and then now we have new, we just put it back in the waiting for eligible. So pretty simple. And that's it. It's slightly longer, but I think it's a very straightforward solution. We just grab the most frequent one first, and then for the ones waiting for calling time, we just keep track of them. And so if we run this and submit, it does get accepted. Okay. Yeah, so that's pretty much it. I hope this is useful. Thanks for watching, and see you on the next one. Bye.